Presentation, Preet, and Alex as well, a great primer on table formats. Love to see more shout outs to Iceberg, Hootie, Delta Lake. Always fun to talk about those. So this panel today, we're going to talk about running Spark in production. We got a great group here who have been doing it for many years with a lot of different use cases, so hopefully you all can learn something today. A bit about me, I'm Andy, I'm a product manager at Onehouse. We build a data lakehouse platform that's powered by Quantum, which is our faster, cheaper Apache Spark engine. I'll start with intros. Maybe if you want to start, Bruno, we can start with a little bit about what you do, what platforms you work with, and what types of workloads there's power.
So I'm Bruno. I work at Rokt, part of the compute platform team for running Kubernetes clusters on AWS. And we built a data processing platform running Spark to process data coming from our data lake in S3. So initially we started from EMR, having a few jobs running on EMR. And as we scaled, this was becoming not as cost efficient as we wanted that to be. And because we run already Kubernetes at scale with multiple clusters, we decided to have a cluster dedicated to running Spark applications. So we migrated to Spark on k8s. Now we have a data lake that is about 11 petabytes of data. We push 1 petabyte of data per week. We process 35 petabytes of data per week. We've got 28,000 jobs running every week. And that's pretty much it. Yeah, that's it.
Awesome. I guess you've already shared a bunch, but anything more to add?
Yeah, so we're working at EXL and it's not working within specific vendors. We are across all the clouds and recently started using Databricks to solve healthcare problems. One of the most interesting use case that we have worked in, which I mentioned, on detecting the kidney disease at an early stage. And the biggest size that I have personally got a chance to work on, the data is around 500 gigabytes. For the historical records, and for the incremental it used to be around 50 to 60 gigabytes. Yeah, thank you.
Yeah, so in DataFlint we actually support teams that using Apache Spark. We support across many platforms including Databricks, EMR, Spark and Kubernetes. But to complete the picture and give like rundown the major platforms, they are Moderator and EMR.
Awesome. So the first question for maybe Bruno, you could start here is how did you choose your platform originally? So when you chose Amazon EMR to run your Spark workloads, and then later chose your own Spark on Kubernetes.
So funnily enough, someone decided to deploy the Spark on k8s operator in production one day. Thank you, Jimmy. And asked me to make it production ready. So it started this way. But yeah, jobs aside, so we are running stuff on EMR. Because we run Kubernetes already at scale, there was a big push to reuse the infrastructure that we had already, reusing the security that we had in place, or the observability. It didn't make sense for us to have two different ways to do some data processing for the process workloads. So we did that migration to Spark on Kubernetes. We saw a big or very easy adoption of Spark on Kubernetes, the way we designed it. Jake over here at the back worked on that as well, designing the solution, implementing it. And we made it quite easy for the teams to run Spark on Kubernetes and abstracting completely the infrastructure for them. So we have machine learning, we have data pipelines just for machine learning, so generating the data sets and training models as well, now running on Spark. And yeah,
Awesome. Yeah, what are some of the advantages of that platform?
Yeah, advantages, I think it's mostly around the cost and the scalability. So when we were running on EMR, it was not flexible in terms of instance types, for instance. So you have to specify which instance you want, and it would be all of the same spec. Running on Kubernetes, you can be more efficient, especially at scale where you can have several types of Spark applications running on the same compute layer. And this is fully abstracted with Kubernetes. We also migrated to ARM instances to make it more efficient, and also leveraging spot instances as of 2 months ago, driving the cost down even further. So compared to EMR, I think we run at less than 50% of the cost of what we're paying to commission.
Awesome. Yeah, that makes a ton of sense. And then Preet, saying to you, maybe with a few of the clients you work with, you mentioned Databricks, are there other platforms, and if so, like how do each of them come to the decision to choose those?
So we usually first ask like what is the kind of data that we are dealing with, and because we are in healthcare, we always come across PHI data, so we need a tool that firstly stores the data securely, and also like how complex are the transformations. So generally in case of EMR, transformations are super complex. So we always wanted a tool where, for example, the client that we worked with was previously using ADF for orchestration, different tool for ingestion, different tool for BI, different tool for handling data governance. So the first condition was like we want a tool where everything can be done in one place. We don't want to keep on learning new tools again and again. So that is how like they decided to choose Databricks. There are other factors as well, but we can discuss later here.
Yeah, so when talking EMR, usually like you didn't choose it, like someone choose for you. Because a lot of times it's a legacy option, the stuff that already exists. But it has some advantages. It's like managed by AWS, you don't need another vendor like Databricks or Onehouse or Rokt. It's already there, you don't need approval usually, like security prefers that. It's relatively straightforward, you set it up and run Spark on that. And be surprised, but we work with few clients that migrating from Databricks to EMR because Databricks would be pretty expensive, and EMR, if configured correctly, could be pretty cheap. And also EMR is a new offering, it's a serverless offering, and the EMR EKS offering, which modernize, like using the same API as AWS, but modernizing the actual infrastructure as they do.
Awesome. So the next question is around any challenges that you guys have seen running in production, whether they're specific to the Spark platform that you're running on, or in general, just based on the type of workloads that you've used. Maybe Meni, you could start again here. You've probably seen plenty of these at DataFlint.
Yeah, we basically see on three agnostic platforms. Start with EMR. So EMR configures the auto-scaling for an EMR cluster, like where to scale, when not to scale, can be pretty challenging. You need to decide both on the, like, you have a lot of flexibility, which will lead to amazing performance. Like you can define the fleet of resources, sheet types, and dynamic version in Spark, and very complex rules, but it's hard to set up and to figure out. It requires a lot of Spark expertise. So that's for EMR, one of the challenges that we see. With Kubernetes, Bruno will discuss it more, but it could be pretty complex to set up, like the initial setup. And for Databricks, it's very simple, but could be also very expensive. And in some cases, again, it's like onboarding new vendor.
The biggest challenge that we face is usually first the integration of data from different sources. In this project, like I would say around 30% of the data was even coming from PDF and even Excel formats, which can't go great with Spark. So handling like all this kind of data, even the images data, because a lot of EMR companies who just scan your, there are still companies who just go like handwritten and write stuff rather than just on the digital. So that's one of the challenges, integrating them. And yeah, second is the cost as well. Like Databricks is cost, it's not something like once you start using it, then you will find it costly and then you will find another tool to migrate everything. So just because they had a requirement of identifying the patients very in real time, and it was very sensitive, they can't wait, or the vendors they are purchasing the data from, they can't wait for the results. So that is why like the time, so that is why like Databricks was cost effective for them.
We'll talk a little bit more about like that real-time requirement and how that plays with Spark, like what kind of trade-offs you need
Yeah, sure. So, usually what happens is if you have batch and streaming in the same pipeline, you usually end up creating different tables, one for the batch and one for the streaming. But we didn't want redundant data. So we want everything into a single table. So, and like Databricks, because of the ACID properties and the Delta Lake, you can have the batch and streaming both function together. So you don't have to wait for the first EMR pipeline to get completed and then start the second EMR. All the EMR pipelines can go at the same time so that you can complete the entire, like the pipeline for the incremental data all together. So that helped with the batch and streaming.
Awesome. Cool. Then Bruno, any pitfalls or challenges you've had with the Spark systems, especially maybe running it yourself on Kubernetes?
Yeah, that requires a substantial investment initially if you want to run Spark on Kubernetes. If you use something like Databricks, EMR, just put your credit card details in, create an account, off you go. Running that on Kubernetes, you need to have a team setting up the platform for you. That will take a bit of time. It's a lot of trial and error, and then we'll have some form of adoption with some workloads running in beta version until you get something that is stabilized and production ready. So you need to invest time and have a team dedicated to working on this. This paid off for us a lot, especially because we have Kafka, Cassandra, and all the different data services that we use internally running on Kubernetes a lot. So it's a bit easier for us to get a full visibility over the workloads, what's accessing what on Kubernetes. And also easier for us to allocate the cost back to teams and services, having everything running on the single platform. So that would be some of the benefits that we get in the long term.
That makes sense. Are there any other challenges that were especially difficult since you're working with large scale data? Anything that's interesting to call out?
Several things. We had a big push towards optimizing for cost and making the platform more efficient. This has been challenging because we have a lot of Spark applications. We have some large jobs and small jobs running, and trying to optimize everything is very hard. So we need to delegate that to the team to make sure they run efficiently. And that's something that the team is trying to scale in probably a smart way and clever way using different AI tools today, or things like DataFlint is helping quite a lot. So we need to optimize at the infrastructure layer and at the application layer. And that's taking time from the different teams to work on that.
Interesting. So I think that gives us a good rundown of the platforms and challenges of Spark. I know something that a lot of people here are probably wondering about is AI and machine learning. I'm seeing a lot of people still using Spark for it. There's also, Bruno and I were talking about Ray as an emerging technology for this too. Would love to hear all of you guys' thoughts about how you're using Spark to work with machine learning, examples, whether it's for feature engineering, fine-tuning, training, where Spark is good, where it doesn't make sense. So Preet, you can go ahead.
So the team that I was working with, they didn't have Spark developers, so that is why they got EXL onboarded to solve this problem. But still, they are filled with the data analysts, and they don't know Spark, and they still want to analyze the data. There are hundreds of tables. So in the Databricks, there's a feature called EIBHN. So what it helps by doing this, it's used for it's much more than LLM. So let's say you just have access to some of the tables, and that too you have some row level security access only. So that tool, you just have to write in simple English language, give me a list of the patients who are suffering from this or this, and just write in English, and it will give you the results in just few seconds in whichever format you want. So this is one of the good use cases for them because it didn't require any kind of knowledge to write the SQL queries or understand which tables it's coming from. But yeah, we did have to train this to make sure the results are correct.
Cool. So one of the challenges that we're developing DataFlint is customers that using Spark to read a lot of data and then run some machine model on top of it, or make billions of rows to run how many prompts. and notice benchmarking multiple versions using like the need to read data someone using Spark, how to run like a model after it. So we saw them testing just sending it to a vendor like OpenAI or Gemini and like in batches and getting results. We saw you trying to like get GPU machines and run it like directly on the machines. On that level, we say that EMR improved. Like in the past, we needed to define like a new CH group in the Linux level to run the GPU, and for driving it was still really hard. So now there is like one flex that set up everything, so they did their job. But the most popular option currently is sending it to Bedrock. So Bedrock has like a batch API, so you can read from Spark, send the batch of data to Bedrock, like an API call, and get the results.
So we use Spark for many different things in our ML pipelines. So we use Spark for feature engineering and generation, whether it's batch or online when we do inference. We use that to generate the data sets as well to train the models. And now we also use Spark to train the models, which is a bit weird, but I've seen that running actually. It was interesting. As you mentioned, and we talked about that yesterday, we try to move to some frameworks like Ray, for instance, that are more flexible and platform agnostic, and people can use Ray locally if they want to train the models, for instance, or run some tests. So we try to decouple some of the ML pipelines that we have from specific tools, or try to decouple it from Spark as well for some parts of the pipelines.
So you mentioned trading on Spark, feature engineering on Spark. Would you recommend these? Are there any pitfalls you run into?
Probably not for everything. We've seen a lot of small jobs or Spark jobs that we run for a couple of minutes. Maybe these jobs don't really make sense to run on Spark and to do something else. We have a lot of people or teams doing copy-paste of a job to another one because it's convenient and it just works. It's less effort to do it this way, even if it's not optimal. I guess it's a case by case.
Cool. That makes sense.
Yeah, I remember something.
Are we on?
Want to frame? Yeah. So one problem we also encounter like using Spark is that default behavior when using machines with GPUs is to split like the number of tasks and the number of GPUs. So if you have like 10 GPUs, you have 10 tasks. So it's like real example, like 800,000 prompts. So each task will be like 8,000 prompts, 80,000 prompts, and then like let's say it takes 20 minutes. The issue is that you might lose a machine, like a spot or a failure, and then you need to like do the entire 20 minutes again. And then the job, like this job that should have taken 20 minutes took like 80 because multiple spots continue to fail. So new like there are new and different ways like using inference in Spark that you need to be careful at.
All right, we'll open it up now if anyone has questions for the panelists here. All right.
You mentioned running Spark on Kubernetes. How do you right-size the Kubernetes pods? Like, how do you allocate resources to it? Especially when it's, sometimes you have like Spark functions that run a workload that's very consistent, but if you're processing files, you're gonna have very different resource needs for like small files to large files. How do you generally go about that?
Very good question. It's hard. Most of the Spark applications are over-provisioned because of that. And that's why we have a continuous cost optimization exercise that we have to do. We did a trial with some of the right-size automation tools that were few on the market. We tried that in staging environment, never pushed to production because of stability issues and want to impact performance. But I think trying to automate that would be the way to go in production, especially at scale.
Question? Anyone else? All right.
To
the gentleman that gave on the medallion and on the three tiers of healthcare services. Can you give me an idea of the messages per second on your Kafka cluster and the size of your Kafka cluster? And the second question I have is, what are some of the challenges that you see in setting up a schema registry? You have like different types of data files, so how do you grandfather them to prevent, so that you have a consistent view of the schema registry, so that as you go forward, you're not gonna hit speed bumps, so is that fair?
Yeah, sure. So for the streaming use case, a cluster, like we had to first calculate what is the, so we had different clusters for the historical and for the incremental. Definitely for the crystal, for the historical data based on the volume, there will be kind of big cluster. And
Yes.
for the, pardon?
I understand.
Yeah, and for the incremental workloads, like we used to define the job clusters onto Databricks, which obviously like based on the incremental volume, which is like 50 to 60 gigabytes on a daily basis. So for that, we'll have a smaller cluster size. Now, as far as the streaming data is concerned, so in the Databricks itself, we can have like the streaming stuff from the Kafka. So there's a different tool outside of Databricks which will help us to first bring the data inside the landing zone. So from there, we can bring the data inside the Databricks is in the streaming part. And the challenge that we had was to make sure it comes, we don't want the late data to come inside the Databricks, so we want to make sure it comes in the exact sequence. So in the Delta Lake, the JSON files are stored in the same sequence the data is coming. And sorry, can you talk about the second question over there?
What's about the schema registry? How do you handle the, different schemas, whether it's for JSON or protobuf or?
Yeah. So what we do is like for the bronze control table, which is supposed to bring the files. The files could be JSON format, it could be CSV, it could be any formats. So we used to have a column for what extension the file is, and in the code of the PySpark, we used to first scan like what is the format of the file that's coming in, and for that specific format, we used to have specific code written. For example, if it used to be Excel, there are blockers in Excel, like we can do some parallelism on Spark, we can't write. So there's a different code for that. For the CSV, there's a different code, but we are making sure that it's stored in the Delta format.
Mhm.
The final table format is fixed. The incoming can be different, but we can meet in that in the metadata.
Thank you.
Thank you, sir.
All right, any other questions? Okay, thank you so much, everyone. Thanks to the panelists. And thanks for having me.
Yeah, we have the menu until 8, so